Question number 8. A cylinder of base 50 mm diameter and axis 70 mm long has a square hole of side 24 mm cut through it, so that the axis of the hole coincides with that of the cylinder. The cylinder is lying on the ground with its axis perpendicular to VP, and faces of the hole are equally inclined to HP. A vertical section plane inclined 60 degree to VP cuts the cylinder into two halves. Draw the sectional view of the cylinder and draw shape of the section. Here is a hollow cylinder with a square hole inside. Base diameter it is 50 mm and the length is 70 mm. Lying on the ground means HP with the axis perpendicular to VP. So in the front view you will get the circular base. Cutting plane is actually inclined to VP perpendicular to HP at an angle. It's inclined to VP by an angle 60 degree. So this is the question, and we have to get the orientation. It should be like this. We watch again. We can watch again. It is having a square hole inside. The angle of the cutting plane is 60 degree with the VP. Again, this angle is 60 degree. This angle is 60 degree. This angle it is 60 degree. Now let's look how it can be drawn. First we have to draw the front view. It's a circle, and also this square hole with all its edges equally inclined to VP. Equally inclined to HP. This angle is 45 degree. And projecting from the front view, you will get the top view. Top view, the length is 70 mm. This is 70 mm. Now at the middle, the cutting plane cuts the mid of the axis at an angle 60 degrees. 60 degrees given here. Now, how to draw the true shape? For cutting plane cuts this face here. So project from there. You draw the axis of the true shape like this. 1 5 line parallel to this cutting plane. Now when you project a perpendicular from this point, you have to measure this distance from this point to the outer periphery. That has to be marked here on either side of the axis, from here to here and from here to here. Now we are taking the second point here, that is this one. This point is passing through, its front view passing through this one. So from 2 when you draw the perpendicular, this point has to be here on the axis. Then this distance will be equal to this distance. From here we are measuring this distance and marking these two and these two. Now coming to this point, third point, we have to draw a perpendicular that is not shown here. This perpendicular has to be drawn. Then taking this distance, we will mark this point, and same distance taking to this side, you will mark this point. We will mark this point and this point. How? Taking this distance from this point to outer. from the same distance to here also. We are marking 3 and 3. And now this point, that is here. When you draw the perpendicular, this distance you have to take and mark this 4 and 4. Actually, this point is this one. Now the last point, that is this point. If you project from here, you will get this point. When you draw perpendicular from there, you have to mark the from the center line this distance. This distance you have to take, measure here and mark. Find 5 and 5. Join all those points with your hand. Draw a smooth curve. The outer, the inside it is straight line. Okay, this is the solution. If you want to know the procedure, you can draw. You can watch here. You can watch the procedure here. Angle 60° marked. Cutting line located. Next step will be to identify the four corners of the four edges of the square hole. Distances are measured and transferred. So that is what we see now. This is how we arrive at the solution.